December 2023. It's my parents' anniversary. And we are here for Plutus PBL Live Coding with Gimbalabs and friends. And we've been looking the last few weeks at a lot of different ways to build transactions. It's kind of a thrilling time to be a Cardano developer because everything that used to be really, really hard and undocumented is starting to be a little bit easier. And there's starting to be documentation. But even more so, we're improving the tools because we've recognized their limitations. And so we've looked at some ways of building transactions on a back end. Mix gave us a tour of Lucid and Apollo Go for that. We looked at ways to not need a back end at all and to rely on Game Changer, for example, to build those transactions. And Martin, I know you've been working on that. And we've been using the first version of the Mesh SDK in a lot of the examples for this course. So anybody who's been through Plutus PBL, maybe you are familiar with what we show you about Cardano CLI and building transactions at a very low level. And then you're familiar with what Mesh.js provides. And one of the things I think a lot of us have recognized on our own, and we've even talked about it in this space, is, man, why does Mesh have to be so different from Cardano CLI? That's frustrating. Why can't I just build transactions the way I already learned how to with the CLI in a library like Mesh? And so that kind of brings us to today. That work is ongoing. It's not just us who have had that idea. I know that Jingles has had that idea for a long time. I know that Abdel Karim has been working on refining a better serialization library to make outcomes like this more possible. And Hinson, you kind of took the lead on implementing an early version of this new transaction builder. Am I getting that right?
Yeah.
And so today we get to take a look at it together?
Yeah, sure. So should I start now?
Yeah, thanks as always for these technical demos. I'm really pumped to see what you got today.
Yeah. Actually, I'm pretty excited for this release as well. I've spent a day today to test around these features on my multiple projects, and the experience is kind of nice. So maybe I could just start with walking through the documentation by a bit. For all of the lower level transaction building documentation could be found on the Mesh.js website, transaction, and then below we have craft, customized transactions, and also Mesh case builder or APIs. It gives you kind of a overview of how to initiate everything and how's the core features and how to let's say mint Plutus token or unlocking Plutus value as well. So we coming from here to craft the customized transaction. Everything starts with initiating the instance using this new Mesh TS builder. So in this Mesh TS builder, you can pass in 3 different fields. Those are the core fields that we will be using for a lot of time. So first is the fetcher, second is the submitter, and the third is the evaluators. So it depends on how you're going to use it. Like if you pass in the fetcher, when you're building a transaction, when you specify a transaction input, you could just omit the value input in the transaction building process. It's pretty much just similar to the experience of using Cardano CLI. Because when we're using Cardano CLI, for most of the time, we just have to pass in the transaction hash and ID. And because the Cardano CLI is quite closely coupled with a node service that you're running in the server, so it will help you to query the value to help you to do the transaction rebalancing and so forth. But here we have implemented the similar features by you could just passing in the fetcher and then we could do the dirty work for you. So second is about the submitter. It's pretty straightforward. Is that after you're building the transaction, you could also use the instant to submit the transaction. And it's a bit interesting to look at the evaluator. It is something that currently we support Maestro and also Opmios. You could pass in the both instance, and when you try to build the transaction at the end of it, if you have any of the smart contract actions going through with your transaction, like minting Plutus token or unlocking script inputs, we will send the transaction to the node service, help you to evaluate it, calculate the execution units, and then help you to optimize the fee to be paid for that particular transactions. So in our demo today, we will try to use all of the three FAS in order to build our transactions. So here are some of the very quick demos on how to build a simple transactions, more complex transactions, and then if you are not comfortable with let's say using the fetchers instance, you could also build a transaction without any dependencies, just like the usual way when we're using Cardano civilization library, where when you're passing in the transaction input, you're also going to pass in all of the details on your value and also address, so that we don't have to go into the node service to help you to query for these missing informations. So if you're going to build a transaction without dependency, you complete the building by complete sync. But if you're going to build it with dependency, you can just do it by using a complete. Well, also it is also an async operation where you have to do the await. But when you're doing the synchronized building, I remember it's a bit error on the documentation. Probably we don't have to use the await here because there is no service queuing behind the hood. Yeah, and there's also one very cool features is that if you're familiar with the kind of the Cardano CLI like transaction building process, you could use the identical APIs, but it is also supported for building a transaction by passing in an object, and we have the detailed schema of the object, how the object be supported in order to let's say building a transaction just through an object. And on the lower level of how does all these things work is that when you are passing in different flags or methods in building the transaction, we are just actually helping you to put in the information in the correct position for an object. So at the end of it, when we call complete or complete sync, it's actually just looking to the object so far and then build a transaction at the end of it. So there's pretty much all of the kind of the details of how it works. And when you really try to build a transaction for your applications, you can take a look into this all API documentations, which is really, really handy. Like it just demonstrates all of the possible actions that you could work with the Cardano transaction, like spending a pub key input here. You just pass in this one. And when you are spending a script input, you need these 5 flags. And when you want to specify an output, it's just doing the TXL is good. And if you also want to attach a datum hash or inline datum, here is some of the very quick demonstration on how you could do it. Also, when you want to do the reference input, this is a simple way to do it. Minting policies, Plutus maintains. We have all of the kind of the documentation supporting different use cases. What makes it better for a backend application is that we have the signing process supported as well. Like here, yeah. Let me see. Yeah, here you could pass in the signing key generated directly from the Cardano CLI. You just have to pass it here, and after building the transaction, we could build a side transaction by the method of complete signing, where we will take a look into all of the signing key you have passed in so far and help you do the signing, add it to the witnesses, and then you could directly submit the transaction out of your backend. So, yeah, maybe there's a bit too much on the documentation. Maybe I just directly jump into the actual examples. So in our examples today, we'll cover several different examples. So first is try to build a very simple transaction of sending fund to myself. And then we take reference onto the example 102 modules on, I remember this mesh PBL, right? And also the unlocking example as well. We have the script Cardano CLI equivalent transaction here, and then we will try to build it in this lower level API. And also we try to mint the always succeed, and also do some more complex transaction like unlocking from always succeed while minting another Plutus token in one transactions. At the end of it, we will try to see how we could use it for front-end transactions as well. Although it's a bit kind of more complicated to use it for front end, but we still do have the example here. And then finally, we have one very simple build transaction from object examples. So to this point, any kind of questions from anyone so far before we really diving deep into coding?
Piotr and Nelson have hands up.
Yeah.
Hi. Okay. I was just wondering, when showing the transaction builder, you were passing only the outputs IDs, and so I was wondering, how does mesh fetch all the data about the UTXOs? Is like one UTXO per time, or do you stack them and then send one URL?
I see. It's actually having some optimization under the hood. Here is that when we build the transaction, we have all of the transaction input stored in the object, right? But at the end of it, when we do the complete function here, and we will try to look into all of your input UTXO so far, and then see if there is any missing information. If there's some missing information, we will do the UTXO querying. But in here, we also done some a bit of optimization, as that if you're building, let's say, if you're specifying different inputs with the same transaction hash but different IDs, we just queue it once, but we store into somehow of a kind of a query histories, and then we will put it in your transaction bodies before really building the transactions. So when we're really building the transaction, we are actually also calling the complete sync function here from the complete. Like after doing all of the querying, we are build the transaction from the node dependency versions. And then if you have the evaluators, and we will do the evaluation and update the redeemer at the end of it. So there's more of the lower level details of how it works. Does that answer your question?
Yeah, that's great. Thank you.
Yeah. Nelson as.
Hi. To use these new features in the front end, do we still need the WebAssembly configuration for the frameworks?
Yeah, because in our dependency, we are still using Cardano serialization library. So we still have to configure for the WebAssembly async flag to be true. Yeah.
Thanks.
Okay. So.
And actually, I had one question too.
Yep.
That evaluator that's now exposed, you showed us that in the docs.
Yeah.
Does that work for any CBOR string that's built by any method, or is that custom to this solution?
I think it's pretty much just work for every CBOR string, because at this moment when we pass in the transaction hash here, it's actually just a typical hash ready to be submitted to the Cardano blockchain. As long as it's in that particular kind of format, you could use these features. But if you want to import these tiny features for your other kind of projects as well, you could just look into the source code here. We have the logic builder in here from this update redeemer functions. So pretty much it's quite portable, that you just copy and pasting this function to your other projects, and you could use it in an isolated manners, I would say. It's pretty much just, yeah. Awesome. We got the evaluation result. Right. But here, before this session, you can see 1 hour ago, I pushed one kind of tiny fix, is that we have a evaluation multiplier, which is the suggestion from the Andamio team. When you do the transaction evaluation, for a lot of the time, we want to multiply it by 1.1 to give it a little bit buffer to prevent your transaction to be failed lane. But in this lower level API here, actually users got the discretion to set the multiplier yourself. Like before building the transaction, you could just amend this kind of variables inside the transaction builder objects. You could just maybe turn it back to 1, or 1.05, or even reserving more buffer, let's say 1.2, it will still work for the evaluations. So this is kind of the logic under the hood. And when I implement these features, I try to leave as much flexibility for the users as possible, so that somehow this is somewhat the opinionated design choice, but I try not to make it too rigid, so that everyone can amend it for different use cases. Yeah.
That's really cool. Yeah, that alone is a huge value add, and I'm so excited. That's part of
yeah. Yeah. So before we are going into the coding itself, I would also like to talk about a bit on the dependencies. So first, I have some helpers on the Cardano serialization library that I have been using in these sessions. It is open source. You could also reference to this library if you see any kind of a string to hash function or passing -32 address to Plutus, etc. Something like this. I have some quite handy util functions for myself that I'm importing for this library. And also there's another very important dependency that's not live on Mesh yet, is that from a demonstration here, I'm using icon scripts. Like here, we have the icon validator, one always succeed minting and one always succeed spending. And I have also implemented the apply param script to the icon script here. And I have everything local here, compiled another WebAssembly package, and then use it in disk files, so that we could just apply the parameters or just building the scripts from the front end. And I would say this feature will be live to Mesh soon, after I've also do some sort of housekeeping or making it work on both Node.js and browser, because currently I'm just testing it on browsers, but it will be also live to Mesh soon. And I'm also using this dependency just to remind that if you want to mimic all of the transaction building from the script compiling to building to submission, probably you would like to look into these two dependency later. So yeah, let me just get started now.
Hinson, is this repo reviewable on the main Mesh repository?
Yeah. This is also another separate repos. I was planning to share the link at the end of it, but if you want to look at it, I could also paste it in the chat.
Thank you. Yeah,
real quick.
That's great. Some folks want to follow along.
Yeah. That there are some answers of the transaction we built in this link. Okay, I didn't find the Zoom bar. Yeah, I got it. So for the answer of this live coding session, there is some completed code built in this repo, but for the demonstration sake, I have kind of deleted the code to be more to-do in order for everyone to follow along the building process. But if you also want to look into the answer, you could just click onto the link, which I have just sent to the chatbot. Yeah, so maybe I could just start now. So first of all, I have this this started locally, and is here. And from here, I just got this little button of getting this script address here. But anyway, it's not that important. The first feature I would like to demonstrate is just on how to build a very simple transaction, which is sending fund to myself. So as I start here, actually I'm using some of the wallet private key and also address which I compile from or I get it from the Cardano CLI. So it's pretty standard process, but we have the S key here. I could show it real quick. This is my S key here, which is a private key. Usually we don't want to share to anyone, but this is just a on the pre-production testnet. And yeah, it doesn't have any real fun. And I have passed the S key here as in our transaction building process. And then the second one is about the address. The address we could get the address from the Cardano serialization library as well. But just for the demonstration's sake, I also very quickly get this address out already and then put it on the environment variables. So finally, we will also have to know the API key for the node service we are using. So these are the environment variables that we need before we start. So first, when we try to build a very simple transaction, so as the documentation has talked about here, let's try to also follow along the documentation as we are trying to, just mimic the new user journey. So when we try to start the instance, we just have to copy and pasting it here. And then basically, this is what we need to start it. Like here, we could initiate a kind of a provider instance. And because Maestro provider is all of the fetcher, submitter, and evaluators, so I could just use the Maestro instance for all of them. But if you have any of the kind of your own preferences on each services, let's say you're using BlockForce to do the fetching, submitting, but you're using Opmios for the evaluators, you could also pass in different providers here. So this is how we start the instance. And then from here, I've also built a very small class where to store every of the transaction that we are going to build. And this is somewhat just for the housekeeping, like because for all of the script transaction that we are going to work with it, we're pretty much just relying on a kind of a standard collateral UTXO. We are not likely to spend it. And the signing key, which is a constant, and also my own wallet address, it is also the constant we got from the EMV. So I just initialize this object quite handily just to prevent just using different variables, importing different variables for a lot of different times. So we could start building on our first very simple transaction, which is sending fund to south. And here we have the code snippet here. And I also prepare something simple here, because these are some of the quite standard operation inside Cardano. Like, because we're using this lower level API, we have to specify what transaction input that we are going to spend with our transactions. But when you really have to get the transaction hash, we have to kill it from the blockchain to know which transaction we want to spend. So I write one very simple helper function here, which is just trying to go into the Maestro instance, query for my current wallet address to see what UTXO we have right now, and then try to filter one of the UTXO having enough Lovelaces. So this is what I was doing here. So at the end of it, it will return a UTXO, which is in the because it's also possibly to be undefined. So at the end of it, I'm just returning an UTXO. This is undefined. Anyway. So at the end of it, I'm returning a UTXO here. And then for the UTXO, I could get the transaction input, or we will understand the input transaction hash and transaction IDs from it. So it's pretty much what I'm doing is trying to look into my own wallet address to see the transaction hash and input. And then here, we could finally start to work with our core logic here, because there are a lot of setups and housekeeping when we really before really starting. So we go into the logic here. We have all the things we need. So how we could get started? So it's pretty straightforward. Is that we could going back to the documentation, look at, because we're trying to sending fund to ourselves, right? So the first thing we need is this transaction inputs. So from here, I just copy the whole thing. and then put it here. And then because here the mesh is inside the object, so I add in this here. And then also we have some inline documentations as well. Like when you're trying to call this method, you can see that what are the possible params. Like here we are suggesting there's a transaction hash, transaction ID, amount, and addresses. And also from the documentation, it specifies what type is it, so that we will not get confused. So from here, because we are relying on the fetcher instance, so we don't have to pass in the amount and address here. So we just erase it. So this is how we have specified in transaction input. And from this transaction, we want to send fund to ourselves, right? So the next thing is that we want to specify the output. So going into the documentation here, this is how we could specify the output. So we just copy this line here, paste it here, and then fill in the information we want. So from here, I'm referencing to the constant wallet address. And then as of the amount, I'm just trying to send myself just a simple love list. Yeah, with the amount. What's this? This is a complaining. Yeah, because we don't need this. Okay. So this is how we could sending the amount to ourselves. So one point to be careful is that the quantity here, we are requiring a string. If you're putting a integer here, you will get some very annoying error which is quite difficult to troubleshoot because I've spent a lot of hours on that as well. This is how we could specify the transaction input and output. And if you're familiar with the Cardano CLI, usually we would also need to pass in the change address, because for the value inside the input, usually we are putting in more than enough for us to build the transaction output. So from here, we also put in our change address, which is also my own address here. And because for this demo, I'm trying to spend the input from my wallet generated from Cardano CLI, right? So the signing key I've already stored in env. So in order to add in this signing key, I just have to pass in signing key. Yeah, also you could refer to the documentations, but it's quite handy that you pass in the same kind of name that we're using from Cardano CLI. And if you ever forgot what to input on it, you could also hover on the method and you can see that we are asking for the private key in Cboard hash, which is either with or without 5820 prefix. So in our env, we have the private key with 5820 prefix, so it's perfectly fine. We just pass it in. Yeah. And then this is all we need to build the transaction. And at the end of it, because in the transaction input here, I do not specify the value and also the address. So I have to complete in a asynchronous manner, which is we are using the fetcher to help us to fill in the missing information. So I just doing the complete. Because this is asynchronous in nature, we also have to add the await keywords here. So this is how we built the whole transactions. And then after we have built it, we also want to cite the transaction. So it's quite simple. It's just using this complete signing flag. It will look into all the signing key you have added so far, and then it will add it to the witnesses. Also, when we are looking to the Cardano CLI, usually we build the transaction first and then we do the signing. So if you want to follow along this pattern, it's okay as well. Like you just have to move in the signing key here. The behavior will be just the same as you are putting the signing key above it. So for the consistency manners, this is somewhat the kind of the coding style I prefer. So I put the signing key above. So here we got the signed transaction. So before we really go into submit the site transaction, let's look into whether this is whether it is in somewhat in the format that we have kind of expected. So we go back to our front end here and try to click the button. Let's see. Insufficient input in transactions. Okay, we have got the error of insufficient. Insufficient. Okay, so here is the issue. Like from here, I try to look for the UTXO with only 2 Ether, but I'm specifying for a 5 Ether transaction. So a first simple trick is I just look for another UTXO here, so that I could have the enough Lovelace to send indeed. So I've saved it and try to do it again. Yep. So this is a site transaction we get. It's pretty much just look like what we usually get when we build the transactions. So also at the end of it, we will do this transaction submission to see if it is passing through. And for the demonstration purpose, I also built a very small code snippet, which has helped me to do the site name submission and also resetting the transaction builder bodies, because we will be kind of reusing the instance over and over again. So I just try to erase the records. And also from here, because I'm doing the site name at the end of it, so I don't have to have this line as well. So I just replacing everything to the transaction hash. Yeah. And then we are returning the transaction hash. Okay, so this is the complete transaction, the first baby transaction that were built from these new features. So let's see if it works. Like after we are hitting this button of sending, it will help us to build the transaction, sign it, submit, and reset, and we got the transaction hash passing back to our function here, and then we will log it out in our terminal and see how it will work. Boom. We've got our first very simple transaction succeeded. So it might take a bit of time for the Cardano scan to have it on chain, but we'll see. So this is how we kind of we can kind of get started with these new features. So yeah, any questions so far? I can see 2 hands up right now. Nelson, maybe.
Hey, so is it possible to get unsigned TX as a string and sign using the previous the previous features of mesh, sign and submit?
Yeah, we will also cover this on the front end transaction here at the end of it. Like we will build the transaction using this APIs, and then we will using the wallet to sign the transaction. I will do the demonstration a bit at the end of it after I've covered most of the APIs we needed.
Awesome, thanks.
Yeah. And PR.
Yeah. So in the last function, there was the method submit and reset. And I want to ask, what's the purpose of this method of the function?
I see. So basically, we have do a couple of things here. Like we do the transaction signing process, and then we submit the transaction to the blockchain. So this is what everything has been ended. But also from here, I also reset the mesh transaction builders body. If you have kind of remember that for the more lower level details of it, is that when we're trying to use these APIs to build a transaction, it's actually under the hood is helping us to build this transaction bodies. Like we are storing up every instruction we have so far, and then when we call the complete functions, we will look into these objects to build the transaction we need. But after we have submitted the transaction body itself is still with the previous information that we have tried with our previous transaction. So from here, you could have 2 options if you want to proceed with your another transaction building. First is that you could instantiate another mesh TX builders, like using another new keywords to have a new object in order to kind of have everything reset as inception. But from here, because I'm kind of reusing this object for my second transaction building as well. So from here, I just do some of the housekeeping of resetting it to the initial state to be ready for the next transaction building. So yeah, I'm kind of in my thought process of whether adding this into the source code itself, but I'm kind of discussing with CY, which is another engineer that delivering this features that for some of the time we might want to look back into the transaction bodies after we have submitted transactions for maybe other stuff. So maybe it still makes sense for us to keep it inside the transaction body objects. Like after we are submitting the transaction, we could always looking back to our transaction body to look for the information that we want to update to our databases or other stuff. So I just make it not inside the kind of the process of completing transaction and submitting transaction, because there might be some needs, afterwards, after transaction building and submissions. But from the section here is more of a housekeeping purposes, because we just have to submit the transaction, build another transaction, submit another transactions. Yeah.
Got it. Okay.
Cool. So for the next example, we will look into the module 102 example, which is the one James have been used for demonstrating how to lock fund in the always succeed script, and also unlocking it from the always succeed, which is the unlock 102 examples. And from here, I want to use this example to explain a bit more of the motivation is that at least for me or some of my fellow engineers getting into the Cardano ecosystem, in a very early stage, we are learning how to build transaction in Cardano CLI. So if you have been aware of the API names, we're pretty much just using the same naming of Cardano CLI. Like TX in, we're just using camel case of it. Case out, we're just using the camel case of it. And as of the order of parameters passing, we're still following the kind of the convention from Cardano CLI. This is pretty much the design choice we have. And so let's say this TX out inline datum value, we're just using the same flag, but in camel case of it. So from in this example, I try to demonstrate how we could do exactly the same transaction from Mesh lower level API here. So let's say we want to build this transaction. I just have to maybe starting from here. Let me show the button, which is sent to always succeed. We got this entry point here, and then example 102 here. But we want to build this locking transaction from Cardano CLI. Maybe we could just copy and pasting everything we have from our Cardano CLI. And then we do the same of starting the transaction like this. And then we could reference to what we are going to do one by one. So first, backpage area. Currently in the lower level API, we are building transaction all in backpage areas. Like in the futures, maybe let's say a month later when the convey error come in, maybe I could add in more flags on convey transaction or backpage transaction. But for now, we are all in the backpage transaction building, so we could just ignore this flag. Second is on the testnet magic. It doesn't matter in our serialization logic, we just skip it. And then transaction end, we have this UTXO transaction end. So we use the same logic as our last example. We are just queuing from the user's wallet or our wallet in the backend, and we have the transaction input and output. So from here, we could just do the EXN. Then here is how we could add the transaction input. Transaction output, we're sending our fund onto the scripts, which is the always succeed script. which are going to lock our funds. So from here, we're using the txout flag here. And then when we look at that, the first param is the address that we are going to send it to. So from here, I've also built some of the helper functions to compile and calculate these script addresses from the icon scripts. So from here, we could directly just use these helper functions. So from here, I've got two. The first one is to get the script cball has, which is just applying the empty param to the compile code directly out of the icon scripts. I could also show the icon script a bit. I'm just importing this build icon script, which I just call icon build after writing the contract, and I have this blueprint. And with the blueprint here, I just doing some simple indexing of which validator is maintained, and another is the spending. And then from here, I apply the param script to it. And after calling apply params to script, it is the cball has ready for building the transaction. Like we usually do with Plutus TX is the same. Like we compile the script and we got the cball has here from these functions. So this is how we are using this get script cball. And from here, we also do the hash of it. And we could start in from here. We get the script hash of it. So validator hash. Because we are trying to lock our value in this in our spending validators. So I'm just getting the spending validator hash here. And from my util functions that I have been using, I have one very handy util function is getting the batch 32 address from the script hash. And if you also try the the package that I built for this util functions. So from here, I could also pass in the state credentials and specifying the network ID. And as I remember, the network IDs is always preset to be testnet. So I don't have to pass in other things as a testnet kind of address. So maybe we can take a look into whether this is really the address that we want to use, or is it looks like an address. So we're going back to here, send to always the same. Yeah. So this is in an address format that we want to look into usually, or at least it looks normal to me. So we could continue with our transaction building process. So from
Just
here,
a question,
yep.
Is also the possibility for staking credentials to the script address?
Yeah, you could also apply staking credentials onto it. Yeah, from this util functions. This is what I have been kind of always using with my devs. Like I always pass in my own staking credential for all of the script addresses, so that when the fund lock it in the validators, you could all still having the liquid staking to the stake pool you have been choosing so far. So yeah, you can play around it after the session if you want. But from here, because I'm not passing in staking credentials, so it's just a enterprise address, which is a shorter one without staking informations. And we are doing the spending examples on that. So I think it's fine. So from the TX out, the second parameter is the amount. You can see in this inline documentation. So I just pass in the amount in the mesh amount format. And yeah, from here, I could also demonstrate one very cool features that we have been built on this lower level API. Is that because from this TX out, we are going to attach with some datums, right? If we are going to attach a UTXO with datum, there's mean UTXO needed. So that in that sense, we want to calculate what exactly is the mean UTXO we need to lock the output inside the validators, right? So from here, we don't have to specify any. This is some of the features that we have been implementing in this lower level API. So we could directly passing in a empty array for the value. It will calculate the mean UTXO needed and help you to directly pass in when you're building the transaction building process. And from here, we could proceed with another flat, because here the Lovelace to lot will be kind of resorted by the auto calculation functions we have implemented. We just pass in the empty and it's fine. And the next is EX out inline datum value. So pretty much it's just identical to the flat that we have been using in Cardano CLI. And from here, we are passing in the mesh data type, which is you could just refer to the typical mesh type. And from the mesh type, it supports just passing in the integer. So I just pass in integer as a datum. And then we go with change addresses. Those is pretty standard. Pretty standard is a change address we have been using. So this is how we build the transaction. So we have kind of mimicked the locking always succeed transaction from here. And because we are going to submit from a backend, right? Like in this example. So we also do the signing from these angles. So this is what we would do when we are trying to mimic the Cardano CLI transaction. You just look into the option, kind of the things that you have been using in Cardano CLI and look at it one line by line, and then trying to importing the method that you want to use. So this is the complete example of building example 102, which is locking Lovelace into the always succeed script. And then let's see what happened if we try to submit it. So from here, from the outside, we're queuing for 6 ADA UTXO, and then we will lock out the transaction hash. Boom. It's another transaction passed through. So maybe we could look into our previous transaction. Yeah, this is our simple transaction of sending fund to myself. And maybe just wait a moment and we could also see this transaction. So up to this point, any questions from the floor on how to sending fund to the validators with inline datum?
This is a really well-structured presentation. Thank you.
Thank you. Got this comment from an educator is my pleasure. Okay, so maybe we could go for the another example, which is the unlocking the transaction input that we have just locked it inside the always succeed. From here, I also made my button appeared from here, unlock from always succeed. But because we are going to unlock it, right? So it's live. So we could take a look into the Cardano scan to try to make sure it's actually what we are expecting. Like from the previous transaction, we are locking it inside the always succeed validator with an inline datum. So when we look into the UTXO here, we could see this is our address from our always succeed validator. To get the proof, I prepared this button. You will see that is GHN at the end of it, and then GHN at the end of it. So it's actually indeed the validator address that we are trying to spend into. And then from here, we have the inline datum, and we could inspect it, and we could see it. Yeah, this is a 1618 that we're trying to lock into it. So so it kind of demonstrates we have successfully locked the value into the validator with the datum, inline datum we want. So the next thing is we try to spend it from it. So we also have the kind of the identical Cardano CLI snippet here, but in this example I tried not to rely into the Cardano CLI transaction because from here I've already demonstrated how to do this process. So maybe from this example, I will try to look into the documentation to build the transaction we want. So first of all, when we are unlocking a transaction, for most of the time, we also want to have the transaction input information from my own wallet address to pay for the protocol fees, and also maybe there's another additional min UTXO. So it's always good to have another transaction hash and ID from my own wallet to start with. And then because we are trying to spend from the validator, right? So the next thing we want to do is going back to the documentations, and then we find, let's say, setting script input here. We are trying to spending the script input, and from the documentation here, there's some kind of the Cardano 101 onto what is the condition we need to spend the input from script. But from here, a more handy approach is we just copy and pasting the code snippet here as a start. So we got the code snippet page from the front end documentations. And then, yeah, we can start from here. So first of all is that we have to have this flag to notify our instance that we are actually spending a script input. And the second is we want to pass in the transaction input information from the script input we have from this flag. So again, because we have the fetcher instance, we don't have to pass in the amount and address. We only have to care about the transaction hash, and let's see. Yeah, we just have to carry, we just have to worry about the transaction hash and the transaction index of the script input. So from here, I do a query. I have something to put reference on, but we just do the typical node querying. From here, I could fetch address UTXO. Yeah, and then we want the validator address, so we just copy and paste it here. We are fetching the validator address. So from here, I could get the validator UTXOs, and this is in type of array of UTXO, because we are kind of sure that there's only one UTXO. Sorry, there's only one UTXO inside it. So I could just do validate input, which is a validate UTXO, and the first one of it. And as to make this a bit safer, I've also prepared the kind of the early return guard of it, which is to checking if there's no input, we are just returning a log rather than just trying to build a transaction with an error. So from here, yeah, I've got the validator input. So the validator input is in the type of UTXO. And because we are only concerned about the input information, which is the transaction hash and ID. So I'm just going to do it this way. And this is of the type of input UTXO I defined here. So just to make myself my life a bit easier, I put the typecasting here. And then when I pass in, yeah, so I could get the transaction hash from my script. I just querying from the validator address and then try to find the first one and then got the hash. Same for transaction ID. Okay, this is how we could build the transaction ID. And because in our previous transaction, we are spent it into an inline datum. So from here, we are just using this TX inline datum TX inline datum presence. But for some of the time, if we want to just spend it from the datum provided by ourselves, we could use another flag on the right-hand side instead. As a redeemer, because it's always a seed, we don't have to care about it. And I have some util function with I built in my library, which is to build the empty constructor 0. So there's a m prefix is as of it is building to the mesh data type. As of the execution unit, because I passed in the evaluator, I don't have to care about it. But even if we didn't pass in evaluator, we still can ignore this flag, and we will have the kind of the presetted execution unit passing in for every validation. But if in current setting, because I pass in the evaluator, so it doesn't matter as well. And from this flag, we are trying to tell the instance where to look for our scripts. For this flag, it is actually telling about we're using reference script. But from here, because we didn't spend anything on the reference script, so we could provide the script source by another methods, which is using this txin script methods, where we are providing the actual cball. Yeah, from here we could also see the cball heads of the script. So we just do the same thing. Oops. Yeah, script cball spending. This is also from the helper function I have defined earlier. So this is how we could specify the script inputs. So yeah, we have passed through the most difficult part of this example. For the rest of it, we are just building the rest of our transaction we need. So maybe I could just speed it up. Like we are unlocking it to our own addresses. So we could just, using this flag. And then also we are passing in change address. We are also using our own addresses. Because we are also unlocking from the validators, we have to present with the collaterals. So this is the constant collateral that when we use in, just at the start of our instance, is a backend transaction. So I pass in the signing key, and then at the end of it, I will complete it asynchronously. So this is how we build the whole transactions. So the next step is we try to look into whether it could be submitted successfully. Yeah. So looking back from here, we are unlocking from example 102. We call the function we have been built, and then we will lock the transaction hash. Okay. Time for magic. Boom. There's another successful transaction built by this lower level API. So maybe after half of a minute, we could say it here. But maybe I also do a pause here. Any questions up to this point? Yeah. So far, so good, right? Nelson.
Yeah, I was just wondering about the previous transaction that is locking the funds to the contract. So we didn't provide any input to it, input amount to it. So it's basically calculating the amount necessary to hold that datum, right?
Yeah, exactly.
Okay, so in the CLI, I think it's possible that we don't provide a datum and the fund gets locked to the smart contract forever. Does this API have safeguard to that? Or I mean, is it possible that you don't just provide a datum to that specific transaction, and will it go through, and what will be the amount in that case?
Maybe just take a look. Let's try it. I'm not sure as well. Send it to all races.
Let's burn some test data.
Okay, it's a set as well. So probably it's just also calculating the mean UTXO needed to send to this address. But yeah, let's see how is it actually. I'm not sure either. Maybe meanwhile, me I'm not sure how to pronounce your name.
Sorry, it's Mix. Don't worry.
Mix,
Thank you, Hansen. Great stuff. But my question is regard to collateral. Does Mesh care about that UTXO to be like pure UTXO, or if that collateral contains some asset, it is fine? No, it has to be a particular UTXO.
Yeah. So I think as of the collateral, according to my understanding, it could be any UTXO, whether it is containing any other assets or not. It will be fine in the serialization logic. But from here, I just try to randomly pick one UTXO. And normally when we try to build a transaction input collateral, we also have to provide the amount and address information on it. But from here, because we have the fetcher instance, so I also do the auto fetching and help you to completing this. So not sure if I answer your question.
No, it's fine, thank you. But sorry, maybe it would be kind of another question. Like, can we add different UTXO from different wallets, like kind of a multi-sig, or
I see.
no, it has to
It's
come
possible.
from one. Yeah,
It's
okay,
possible.
thank you.
If you want to do multi-sig, you just have to pass in different signing keys here. If you want to do the multi-sig on the back end, like if you want to let's say do one signature from the back end and one signature from the front end, it works as well. Like when you build a transaction, you pass in one signing key here, which is your backend signing key. And at the front end level, you could always pass the transaction back to front end using this. And then you could always start the transaction again from the front end. But one point to be aware of is if you're doing the multi-sig, you have to remember to move this flag to be true. Like when you're signing from the wallet, this is telling you are partially signing the transaction. So it will not just keeping to look for another kind of signing key from your browser wallet, but it's failed to look for it. So, but answering your question is possible. Like you can just sign it for any time you want, as long as it's under the protocol parameters of 16 kilobyte transaction size. Because when you sign it with different more wallets, it's just appending to the witness set. We will bump up your transaction size when you're doing the submissions, but it's possible. Yeah.
Great. Thank you.
So
but maybe another question.
yeah, sure.
Have you guys add to this low level transaction building script evaluation as well? Like there are some endpoint in different blockchain. Of course, there are native kind of Plutus engine, but I don't know with regards to printing the smart contract errors or calculating the execution unit and memory, all this stuff.
So for this evaluation logic, we have relied on the iEvaluator instance, which Mesh has been implementing. So far as I understand, there's Maestro and Andamio having the evaluator functions available on Mesh. So you could either pass in Maestro or Andamio in the instance. And if you have passing the evaluator flag at the end of the transaction building process, we will also set the API core for the evaluators to see of the execution unit or if it's successful or not. Like if your transaction is invalid, it will return an error somewhere here. Like you could see it from your console when you're building the transaction. Yeah.
Great.
So it's supported by Mesh evaluators instance. Okay, so going back to our previous questions, if you're not submitting with, if you're not locking the value with a datum, it's actually still pass it through to the always succeed script. Like I think the logic here is that when you specify a transaction output without a value, it will help you to calculate the mean UTXO needed, even though you are not attaching with any of the inline datum or data hash or any other token. It will still help you to calculate one output to that particular address. So that's a behavior of this lower level API.
Got it.
Okay.
Yeah, thanks.
So the next one, we will do some minting examples. And I try to, do things a bit quicker because we're not having much time left.
This is perfect, man. And this lecture can be split up into parts and used directly in the Mesh PBL course. Really
Yeah,
cool.
yeah. I think it would be cool as well. Yeah, from here, because we are going to mint the always succeed token, right? So we always start with this transaction input from myself. It's pretty much just identical to any other transaction we have been built. So the next one is that we want to mint the Plutus token from the always succeed script. So we could going back to the documentation to see mint Plutus token. Same, we just copy and pasting everything we need. And here, firstly, we have to tell the instance that we are minting a Plutus version 2 token. And then second, we're specifying the quantity we want to mint. Let's say I'm going to mint 1 of the token. And then the second one is the policy ID. And then the third one is the name. And yeah, so we try to get everything here. So as of the minting script, we have the helper function built here. So we just use it. And we got the minting script seaboard. So this is in the format of the one we usually compile from the Plutus TX. It's the same, but it's an icon script here. And then the second thing we need is because we are going to do the policy ID here, right? Policy ID is indeed the script hash of the seaboard that we are having it right here. So we just have to get script hash. Yeah, we're just using our util function has been introduced earlier. So we got the policy ID here. And as of the token name, we could just be anything. But one point to be aware of it is that when you look in hover onto the inline documentation, it's a hash of the token name. So it's not directly passing in the token name in UTF-8 format, but we are using hash. So from here, I have a very simple util function, which is string to hash. And then live coding test. So I just make it this way. And then I pass it in. So this is how we compose the mint one. And so as of the script source, because we do not spend it to on-chain for the reference script, so we just provided that using the right-hand side endpoints, passing it directly to script seaboard. Minting value, same because it's always a set. So I just got one kind of the empty constructors and I ignore the execution unit. For the rest of it, I just doing the same. Like I'm sending it to myself. But from here, I want to specify I'm receiving the token we have minted out of this transaction. So I just do this. 131. Yeah, I just doing the specification. But same because from here I could from this lower level API, I could just specify the token I want to spend to myself. And it will help to calculate the mean UTXO needed to be attached with this UTXO. So the next is something pretty standard, change address, async collateral, and then signing key, and then complete. Pretty much the same. Here. Okay. Yeah, I'm just wondering why there's deep tracking. But anyway, yeah.
And in that TX out on line 129, we can customize the amount of Lovelace now, right?
Yeah, we could also customize. Like you could also pass in another, which is unit Lovelace. And then you could just, pass in any Lovelace you want. But from here, if you ignore this flag.
Yeah, that was on our wish list. Thank you for that one too.
Yeah, so you could pass in a Lovelace if you want to kind of satisfy any of your script logic. like if it's checking on the script level that you have two either as per main UTXO, and it's fine as well. You just specify it's two either. But if currently in this example, I do not care about how many either is going back to my own wallet, so I could just ignore it and it will automatically calculate the main UTXO needed. So from here, I have this mint always succeed. It's using similar logic here. I got six either UTXO from my wallet and then build the transactions. And then let's see how it goes. Yeah, mint always succeed. Boom. There's another successful.
Again.
Yeah, there's another successful transactions. So yeah, up till this point, any questions? Okay, so I think it's so far so good. So I just very quickly go through the next example, which is something that I want to demonstrate with a more kind of complex transaction, which is unlocked from a validator and also maintain another Plutus token. But because we don't have any value in the always succeed, so I just send another value into always succeed before we getting started. Okay, so from here we could pretty much just doing the same thing we have been doing with the minting transactions, because in this example we also want to mint something, right? Let me see what this is. Yeah, we are doing the token name. I just try to specify as we are trying to unlock it. Meanwhile, we are minting another Plutus token. But from here we have every logic we have on minting, right? But we also want to add back our logics on spending from the validators. So we could do it in this way. We're just composing the transaction from what we have so far. Okay. So I think I got it correctly. The git trace tell me the answer. Okay, this is very quickly on how I could compose a more complex transaction. Literally, the transaction building process, if you're doing it from scratch, it's just the same. Going back to the documentation, copy and pasting the code snippet you need, and then just modifying with the informations that are particularly made for your transaction, and it's fine. But from here, I very quickly compose it from what we have so far, so we can also test it. Oops. This thing require inline datum. Because we have spent another, if you remember, we have tried to test whether what is the behavior of the one without any inline datum. So I think it has cached a UTXO without a datum. So it's kind of locked inside the script. So I need another UTXO, which is the second one coming in, which is I've just spent it into the script. So let's see. Yeah, so it works. Unfortunately, because we from the testing transaction, we did not spend any datum into the script, so it's kind of permanently locked inside the always succeed script. And yeah, so from here we've got the examples of a more complex transaction, minting Plutus token with unlocking from the validators. Let's go for the front end transaction, because I think this is another quite interesting topics as well. I try not to build everything here because it's pretty just similar to what we have so far. And as of the front end interaction, I'm just using the standard mesh hooks we've got so far, which is I use the use wallet hook, and I try to connect it to my eternal This is just hard-coded to be connected to Eternal and show into the front end where we connected our wallets. And then from here, I query the unused address as the address sending to my own addresses and change addresses from the front end APIs. And then as of the transaction input, I try to get one with 3 adders just from my accounts. This is just also using the wallet APIs here. And then I will do the same transaction building process. And then just for a bit of the handy purposes, I still use the complete signing flag to get my build transaction. Because if you do not have any of the signing keys specified here, it will just do nothing but return you a build transactions. And then I do the transaction signing here using the wallet APIs. At the end of it, I will submit it. So let's see how it works. So firstly, I have to connect my Eternal wallet and then do the front end transaction. Yeah, from here, it's just a simple transaction sent into myself. You can see that it's 2 Adder. This is what I've specified in my transaction. Boom. So that's how we could work with this lower level API with the front end transaction. But something you should be aware of is that currently we do not have the UTXO selection part onto the front end transaction, because when we're using the higher level API from Mesh, we will do the UTXO selection for you, like picking which one UTXO is needed to build your transaction. But from here, I kind of do it manually, like picking the UTXO with 3 Adder, because I know that from my transaction output, I only need 2 Adders. So this is somehow of the transaction building process if you wanted to use it for front end. So I would say for this moment, at least so far, it's more compatible to the backend transaction. Like I build the transaction on backend, do some multi-sig backend, and then I have everything configured correctly on the backend, and then send the transaction back to front end. I could also do the transaction signing from the user side. So somehow still decentralized in a way that there's needed from the user to do the multi-sig, even if it's a backend transaction. So I think, so for this lower level API, it could be kind of more easily used in that direction. So at the end of today's section, I will also demonstrate how to build a transaction from object, because from the website, it's indeed it's telling us that we can also build a transaction just from an objects. So from here, I also got a very handy example. If you want to use this feature, you could import this type of mesh PS builder bodies. And then you could specify the inputs, output, collaterals, and any other things, including the signing key and change addresses or metadata, validity range, anything you can specify with this mesh TS body. As of the schema, you could always take reference to the schema inside the package, or you could take a look onto the front end schema. Like at the end of the all APIs, there's a schema here telling you how to build different let's say the input. This is either pub key input or script inputs, and then you would know what are the flags you have to put in here. Like from here, I also have one very simple example. And then when you're building the transaction from the object, you don't have to do any TX in, TX out here. You just directly proceed with complete or complete sync. And then you pass in the object here as you can see when you're hovering the inline documentation, you're passing in the customized transaction here. And then you can directly proceed with the lightning process and submission. So let me do a very quick demo as well. So this is how we could get a transaction site and submit through a object. So I think, that's all I have to cover today. So any questions or any feedback on this feature so far?
It's incredibly exciting. Thank you, Hinson, for leading this, and to everybody who pitched in. can you just say a word about what version of mesh to look for if we want to be able to use all these features?
Yeah, so currently we have one beta version. I just put that into the very briefly. This is the version that having everything I've been demonstrating, including RTX evaluation, output balancing, and all of the thing I demonstrated I was under this version. And for all of the code example I have so far, we could reference to the link I've just sent out in the earlier of the course. Yeah. Any other feedback?
Yeah, I just dropped in the chat. This object to test to submit a transaction, I think it's super handy to test a quick transaction. Seems
Yeah.
awesome.
And
But
for a lot of the time,
let's say, can we create a smart contract transaction or a smart contract interaction transaction with object as well?
Yeah, basically you just have to specify, let's say you want to spend a script output. I forgot what this mean. Just have to take reference to it. You could always specify the type as script, and then you pass in the missing flag as needed, like the script tx in here. We have script tx in parameters. So we have to specify these things. So for script, it's a bit more complex, but the gist is that you could just reference to the type signature of the object and then just build all the thing we need. Yeah, if you want to expand it from script as well.
Great. And maybe my last question. When will you add this boom function? You know, after the transaction submission, this boom function, you say that boom, it is submitted. Maybe we would love to. That would be great function, you know, like a boom.
Boom. I'll just leave it on the front end. Probably on the back end side, we don't need a boom.
Definitely.
Yeah. So currently it's supporting Firebase transaction and it's defaulting everything of script is in version 2. So I think I will do the upgrade after the convey error is out, so that I have there's also version 3 of the Plutus script supported on a later stage, I would say. But I kind of, when I build this feature, I kind of assume no one is going to use Plutus version 1 script. So I didn't take care of any of the version 1 logic from this lower level API. But probably when I try to build the config compatible endpoints, I will also add them back version 1 support as well. There's something to be aware of. Yeah. Any other feedback?
Yes, please, Nelson. That sounds good. I'm very excited to hear from people who have now seen several different options. I know, I like Martin, Claudio, you guys have been here. Piotr, you've been here to see it. Nick, you've seen a bunch of different options. And then especially I know Adrian and Mix have been thinking a lot about this. How does what you're seeing right now change, if at all, your plans for how you might address transaction building?
Well, to be honest, to me right now, I wonder the benchmark, like comparing, because behind the scene of Mesh, there is Cardano Signature Library, and behind, for example, Lucid, there is Cardano Multi-Platform Library. And I wonder, even between creating a higher API or high-level API transaction building with Mesh and low-level, what would be the difference in terms of transaction fee or any other number? And compared to other libraries like Lucid, again, the transaction fee. And the other point might be the speed. Like, will this low level, because it is low level, would create or craft the transaction faster or like slower than the higher level? Of course, 1 or 2 transaction, well, we don't care about it, but probably if we have high demands, like in a DApp or DEX or something, maybe that would matter. But yeah, I wonder this benchmark. I don't know if Hansen or even Jingles have done that. And maybe I would ask them, like, is there any plan for you guys to support other cores like Cardano multi-platform libraries? Or no, you want to stick with Cardano Signature Library for now, and that's it. Thank you.
Okay, so maybe there's more a bit of experience sharing, and I'm not sure if my answer is perfect, but maybe I just try to answer the speed questions. So far as per my observation, Cardano serialization library and Cardano multi-platform library are quite fast in the transaction building process. But for 95% of the time of the transaction building process, in this is doing the UTXO selection. Like when your wallet having 100 something UTXO, you pass into the CSL or CML, and you wanted to help you to select 2 or 3 to be the transaction input for your transaction to be built. It takes quite a lot of time to do the searching. So UTXO selection is one of the biggest bottleneck of transaction building speed, I would say. And when we are doing this lower level API, because we are specifying the transaction input, that particular transaction input that we are going to spend, so literally we don't have to spend any time on UTXO selection. So it's quite fast in the transaction building process. And another bottleneck I would say is the node service. Like from here, we have the fetcher, submitter, and evaluator. For any of the fetching and the evaluation endpoints, it takes around maybe 400 milliseconds, like 0.4 seconds to do one querying. So this is another bottleneck of the transaction building. But as of the actual speed of the transaction building process comparing between CSL and CML, previously I spent a bit of the time looking into that issue, and then my answer is pretty identical, I would say. They are pretty fast in a sense of just doing the serialization logic because it's written in Rust, and the cryptographic calculation is quite efficient in the Rust package itself. So as of the speed, when you're doing something this lower level API, it's probably quite fast because you don't have to do any of the UTXO selection. And for most of the time, you're waiting for that 1 second. It's just a node service network time between my computers to the node service for the fetching and then building, and then my computer to the node service for the evaluations, and then rebuilding. So I think as of the speed side, this is my kind of answer as per my personal experience. Yeah. And the second part of the question is on the fee. As of the transaction fee, I would say no matter you're building the transaction from any of the library, eventually it will be quite identical. Because at the end of the day, if you look into the source code of CSL or CML, it's pretty much just under the hood having a more complex object like this, like the mesh transaction builder's body. You could probably find the backpage era CDDL to look into the full object specification. But at the end of the day, it's just building the transaction out of the objects. So it's no matter for you to build a transaction in Cardano CLI or CML or CSL or any other off-chain library, the fee will be identical. But what will make the fee a bit different is the execution unit. Like when you're spending a output from the script address or you're minting a Plutus script token, you have to specify your redeemers. And from there will be execution unit allowed for each transaction or each redeemers. So let's say if you have a pretty straightforward scripts, just like our demonstration, which is always the seed one, probably you don't have to use a lot of execution units. But let's say in our previous, if we do not have the evaluation function automatically calculating the execution unit needed, for a lot of the package, it will maybe in the early days of Mesh as well, it will just hard-coded one execution unit for you. In that sense, if you're building a simple transaction, simple script transaction with the default execution unit, the transaction fee will be a bit higher than what's needed. But with this lower level API, because we are suiting an API core to the evaluators, we're coming back and then fixing the execution unit to somehow near to what we exactly need. So the fee will be, just a bit cheaper. But I would say usually it's the most cheapest option is to directly submitting through Cardano CLI, because it's tightly coupled with the node itself. So you could get the exactly lowest amount of execution unit we need to build the transactions. So, but if we could get that particular number correctly, it's pretty much just identical across different libraries. Yeah, hope that answer your question.
Yeah, great answer. Thank you.
Okay. Any other questions or feedback?
Great session.
Yeah.
Amazing agenda, great use of time. I really like the way that you provided patterns for all of us to look at, and then you built into those patterns. This felt like a really, really exciting way to learn. Let's keep it going.
Yeah, hope it's useful for anyone attended today. And yeah, just shoot me a DM or create a GitHub issue on the Mesh on this feature just anytime, and I could kind of improve some maybe features or have some bug fixing if you find any of them. So yeah, hope you guys will enjoy this new feature on Mesh.
I'm excited to play with it. If we continue on this theme, Adrian, what would you think about looking at Atlas transactions tomorrow?
Yeah, we can do that. Then I will provide something.
Awesome. It's such a satisfying time to be doing this work, y'all. Thank you for pushing it on every level. All right,
Yeah.
so we'll have this recording. I know I'm gonna watch this recording and go through it myself step by step, just to really feel these things out, and we'll keep learning together. Appreciate everybody.
Yeah, thank you.
Cool. Bye.
Yeah, thank you.
See you
Thank
tomorrow,
you.
same time, same
Later.
place. Bye, everybody.
Bye.
Cheers.